Good morning. Just give me a moment. I'm still trying to get my Unity open. It wasn't open. Okay, it is taking its sweet time. I should probably... let me just pop out chat while I'm waiting for Unity. Chat, pop out. There we go. Okay, close enough. Close enough. There we go. Okay. So I moved again. For those of you paying attention. I actually, oh, this guy. How's it going, man? Yeah. I moved my desk again. Because yesterday during the stream I realized that there's an even better way of arranging my desk, so I did. Okay, let's see. Yeah, it's annoying with if you have a green screen, right? Because I just want the thing to be there in the background, and I don't want to fiddle with it every day. And that's harder than it sounds. Okay, project. Let's see. And the one benefit this now has, the way that I arranged it now, is that my second screen is back on the same side, so it's not as jarring anymore. And my mic is on the other side, so I get to use my right hand, which is also quite nice. Okay, let's see. So yesterday we were fighting with our little basic enemy, right? And I essentially got to the point now we were thinking about how exactly we want him to follow and group around the player. Alright, so that behavior wasn't ideal, right? If I had to just quickly run through it again, right? So they come, yeah, look at that, they're already running in a line. And if I actually stand still, yeah, the way they bunch together there is not great. They should try and just move around, I think. Because they kind of move around eventually, but it's by pushing each other. Yeah, so that's... I thought about it a little bit. So one of the things I thought Okay, so there's a couple of things I was thinking about, right? So what if... let's open up Paint, right? Paint doesn't need to compile. So we can think in Paint while we wait for Unity to, you know, do whatever Unity does. So this is kind of what I was thinking, right? So what if you do something like this? So you have your player. Let's say over there. I need a thicker brush. Give me the thickest brush. Right, so you got your player. And your player is moving in this direction, right? So it's all about, if I think about it, I want to do it in a way that I want to make small changes that might have a relatively large effect. So I want to make it simpler first. I want to make simple changes first. So what if, right, we did the following. We know the player's current position, right, and we know the player velocity. So what if we just, for now, just as a starting point and see what happens. Now this is not going to be perfect. So hear me out. So let's say, oh, and I also want to do a couple of other things. I want to make the update for obtaining a target less frequent. I was thinking like 0.1 seconds. So every 0.1 seconds, you should, the enemy should obtain a target, right? Which I honestly think is fine. Right, currently it's every frame, you know, and every frame is, I think, what is this? This is 10 frames per second, essentially, right? So this is a 10 frames per second. Yeah, we could get away with 4. Yeah, you're right. But yeah, so you're on the same side as me with this. It's like they are, if you look at the basic movement scripts here, if I can find, oh, I'm in it. Yeah, they are every single frame. So on an update loop, they are doing basic movement, and basic movement runs basic chase player, and basic chase player, it does, well, it actually gets the character position and sets the destination for the agent essentially every single frame. Like, all of this could happen way fewer times, and the player won't even know. And I know for a fact this type of stuff in the background is definitely taking up some overhead. Obviously, a lot of the overhead is just the agent itself, right? Each enemy has a nav mesh agent, or is a nav mesh agent. And I'm not sure this nav mesh thing, how much resources it really requires. Might be a lot, who knows. But anyway, let's get back to Paint. So anyway, what I'm thinking is, instead of giving them this position, right, I could give them the player position, and this might not be perfect, but I could, for instance, give them the player position. So I could do a couple of things. So let's say the enemy is over here. So normally I would do something like, okay, cool, just go straight to the character, right? So what if I told him that you shouldn't go there, you should go where the player's gonna be in, I don't know, 1 second from now. So this is well, okay, this is not quite gonna be right. But let's say we tell him to go where the player is going, based on your distance from the player. So we could calculate something like this. We can say, okay, you are, let's say, I'm gonna do it in meters. So let's say you are 10 meters away from the player, and you move at 5 meters per second. So that'll take you 2 seconds to get to the player in this situation. Now, this is not going to be perfect, but what if I tell him, okay, cool. So since it takes you 2 seconds to get to the player from where you are at, and the player might be moving in a direction at 6 meters per second, we can multiply that by 2, which is 12, right? And we can tell it, okay, don't go straight to the player. Actually go there, where the player is going to be in 2 seconds. Now, this is not exactly perfect, right? Because as the player runs, obviously the distance increases. So it's not a perfect approximation, but it will. I think it's gonna zoosh up the target acquisition a little bit more. So that if you think about it, if you have a character there, or enemy there, and an enemy there, and an enemy there, and an enemy there, ooh, I should actually do that. If I have an enemy here, might be making these guys too clever, and it sees the player is trying to move in this way, I should just make it intercept the player. So what would that look like? Well, I guess this is going to be a kind of an interception, right? Because it's going to say, oh, look, I'm 1 meter from the player. Right? The player is moving in this direction. So the player should be over here in the time I can spend running here. So I'm going to run over there. So it's going to look like an interception. I think if we just did this, like I need a baseline. So I think I could do this and see what happens, and whether or not the outcome is closer to what I'd like, and then we can refine it a little bit more. The only other thing I can think about that might still be a real problem is the overhead of all of this being done in every single character. So as far as I understand, it's not necessarily a good idea to have every single enemy do all of these calculations for themselves in an update loop. So it might be better to do a enemy movement script somewhere else that goes through all the enemies and tells them where to go, instead of them deciding for themselves where to go. And in that way, what I could even do is I could, as it loops through, I could even do things like check, or only do a certain amount of calculations per frame. So I could tell it, okay, so do 5 and then wait a frame, and then do 5 and then wait a frame and then do 5. So it doesn't try to do, if there's like 1,000 enemies for some reason, it doesn't try to update all 1,000 of them on one frame every 0.1 seconds or whatever. So you don't get this, massive spikes in CPU utilization, which obviously would cause a bit of a lag spike as well. But yeah, I'm not there yet. Let's just do the one thing I said just now. Okay. Okay. So the other thing I should ask myself is this type of movement. Do I want all characters to have this kind of movement? And what I mean by that is I obviously have this enemy movement basic script, right? Which all enemies have. And they all have access to a basic chase. And I do believe that is good enough for certain enemies. Like, that is the behavior that I would like from the frogs. Or from the Komodo dragons, maybe. But the lizards specifically, I need to be different. So what I'm thinking is, I'm going to make it different in their own movement script. So I'll take this simple meaty enemy movement, and I'll do these complicated things in this script instead. So that they only are affected, and the rest of the enemies can be using the simpler version. I can always update the simpler version to do the more difficult stuff as well if I really wanted to, but for now it's not really required. Okay. This thing will still get things like the look direction, for instance, so it'll always get the... if I need it, I can always get, you know, where the player is and stuff like this from here. So that's fine. Where do I use the character? Character dot position. Ah, okay. Okay, so the first thing I could do, so public void, set target. Okay, let's say target or set destination. Okay, this is going to be an I. Enumerable. Don't think it needs to be. No, let's do this one, void. Let's just do a calculate destination. We can make a coroutine later to call this function instead. Let's just make the function. If I want to make this the coroutine, I can. But for now, I'm just going to make it a function. Or method, whatever you want to call it. Okay. So calculate destination needs a couple of things. So it needs... I'm thinking about it. What if I could... If I could do something like this... So let's say you have your character, and you know it's the path that the character is going to be on, right? So you kind of know the character's on this path. Right? I'm just thinking about the math here. I'm the enemy, I'm over here. I want these 2 points to intersect somewhere over here. So I guess I could do some quick math. Well, I just do something like, okay, we have this distance. I guess the difficult part is finding out yeah, it won't be precise. Because yeah, if you used, yeah, since we're gonna go along the hypotenuse here, the time needed to travel this distance is less than the time needed to travel this distance. But this distance and this distance are gonna be yeah, so I could calculate this time. I could calculate this time and the distance traveled along that time. But then I need to update that time and I need to update the distance. Because then with the new time, which is a longer distance, it's going to be a little bit further, but then I need to update that time again, etc, etc. We can see how this like obviously they'll reach eventually. I guess as we get closer, the difference is going to be very small. So what I maybe could do is I could just estimate with like a, you know, make this like a 45. Oh wait, I can actually calculate this angle using the speed. Yeah, I can know these two distances, calculate the angle. So if time is constant, so if we say in 1 second, we know that the enemy will travel some distance and the character will travel some distance. We can close that triangle, calculate this angle, and then just extrapolate, and the enemy can know exactly when they'll intercept. Ah, that's perfect. So we can call this like theta. Okay, yeah, I could just do that. I could just do that. Now, this is obviously for a situation where we have them running parallel to one another. Well, perpendicular to one another. Or they'd like to. Okay, so that's straightforward enough. The other problem is if you had the character running this way, and you got an enemy, let's say over here, I would like that enemy to go, say, there to intercept and not just chase behind. Okay, so how would that work exactly? Well, I guess all we have to do is we have to take the character's position in the world, get its XY velocity. Right, so this works perfectly if we just have a X velocity, right? So what we can do is we can break this down. We can say that, okay, cool. We need to add, or in this case, yeah, to calculate this as if it's on a straight line, we essentially have to add the distance that the character would travel to this calculation. Yeah, so essentially what we do here is we say speed of enemy downward, speed of character downward. Right, so that side of our triangle gets a bit larger, and then speed of character in that direction. Then we can close the triangle, calculate the angle, and then obviously extrapolate for the actual point that we want to intersect. The character is going to run around along this line, and yeah, that's perfect. Okay, we can do this math, no problem. Okay, the only thing now we need to do something with the x as well. Okay, we can figure it out. Probably I'm going to get this wrong first, and then I'll have to change it. But this seems to work. Hopefully I'm not overcomplicating this thing so much that the amount of calculation time is going to get ridiculous now, and then the performance kind of tanks. I don't think so. Okay. So, first of all, okay, we want to get the character position and rotation. Do we have that from basic movement? Let's just make sure. Okay, so position and rotation. Yeah, I'm actually not even sure what the rotation would be in. We just need the forward direction. We just need to know. But the character might be moving in a funny way. Okay, so what we need is the input. Yeah, the vector. Okay, let's do some vector math. Now, there's probably a way to do this vector math properly, like with dot product and all those good things, but I've forgotten most of that, so I'm just gonna brute force this a little bit. Okay, so first of all, we want a vector 3 character position, right? And I think I could just do move movement basic dot. Okay, so the movement basic does not expose the character position, or the character for that matter, but I think it can. Right, we could do public. Might be worth thinking about doing this calculation from the player's point of view. Oh, I see what you're saying. Well, yeah, I think I might need like a script like that. Damn. So I was thinking about having a sort of a manager script, maybe instead, that essentially does this calculation for each enemy, right? And then tells them, go there. Instead of this calculation needing to happen inside of each enemy, I have something else doing the calculation for the enemy. But I think I'm going to do it like this first, see if it works, and then I can extract it into some higher order, thing that does it for me. Okay. But I know at least that I'll need vector 3. This is the character move direction. Right, so this needs to be input to equal to my input, actually. I don't even remember how the hell I get like, I haven't used that script in so long. How do I get inputs. Let's see. My player movement should be getting that. Let's see. What are you doing? Vector for angle calculation. What angles am I calculating here? Strafe direction. Eh. Oh, look at that. We just have a get move direction. That returns move direction, which I'm assuming yeah, okay, so that is our input vector. So I could just get move direction. That is literally our input vector. Okay. Well, that's useful. So player movement dot instance dot get move direction. There we go. So we know in which player the character is moving and the character's current position. Okay, now this doesn't help me too much. We need a vector character speed. Now how do we get that? I guess we can ask the player manager okay, get selected character okay dot get components of type character stat manager get movement speed. I think that, what does that return? Oh, this should be a float. What am I doing? I can't remember exactly what this returns. Is this the actual movement speed or the movement speed multiplier? Get base move speed multiplied by the movement speed multiplier. So this is the actual movement speed. AR synth or Arcanth. How's it going, man? How are you doing? We're gonna do some serious vector calculations here in a minute. Hope you're strapped in. Hope I'm strapped in. It's gonna be interesting. I'm doing well, thanks. Okay. So this is at least the first three things we need. We obviously need the enemy position as well, but we know that. Okay, so one of the first thing we need is an angle. Right, how the hell do we store an angle? But just this would just be in radians, so it's probably just a float. Yeah. This is gonna be a pain in the ass to debug, but anyway. Okay, so this is the angle for our little triangle that we got. Okay. So how did we say that we're gonna calculate the angle? So we need to add the components of the player direction Yeah, okay, so we need to get the speed. So we're gonna take this. This is the enemy speed if he just ran towards you. And then we add the player velocity in that direction, let's say. This might break if it goes the other way around, but I don't know. So that's this length, and then this length is the player speed in that direction. That gives us this and the angle, which will give us the time requirements, I think. Yeah, I'm not entirely confident, but anyway. So, okay, we'll have to do... How do we do... Oh, octan. This is how we do octan. Okay. I haven't done math in a while here. Okay, let's see. So we have to do octan of... This might break sometimes, now that I think about it. Which cases will it break? I think if it's octan of 1, I don't know. No, that's just 45 degrees. Oh yeah, that makes sense. That makes sense. Oh, what if the player velocity in that direction is 0? So then that would be octan of 0. Oh, that also works. Gives me an angle of 0. What if... No, wait. If the player velocity... What happens if they are in a line? So if he wants to go 90 degrees... So I'm just thinking about this. So what if the enemy is over here and the player is over here? Okay, so then they are in a line. So if I did the calculation, it's just gonna be for intercepting the player. It won't actually work. Then we just need to run towards the player, essentially. Now, if the player is running in any other direction, it'll be fine. But if the player runs this way, then we have to do this component gets 0, and it's tan of this over this, right? X over y. And if y is 0, it's octan of infinity. Yeah. Okay, so we might have to calculate our y first and check. Okay, so y float y equals. Okay, here we go. Here we go. Are we ready? Oh wait, how exactly did I... No, wait a minute. This is not going to work 99.999% of the time. I need to get the relative positions of the player and the character first. I think so. I'm also not entirely sure in my world now which direction is actually which here. So I'm going to work with the Z and the X. not the y. Okay, so I should think about this just a little bit differently. So I have, this is my z-axis and this is my x-axis, right? Okay, so z and x. So the problem here with the way I'm gonna calculate this is the z. If the z is ever, but I could also do this as a like a local, not absolute. No, but that won't work so lacquer. Okay, I'm gonna, well, it might, and I might just be too dumb to figure it out right now, but I'm gonna make it absolute, and I'm gonna just compare the z's first. So we can do, okay, so let's do z, not a capital, just a z. Well, no, we can do a relative z. So we could do something like if our character position dot z minus our transform dot position dot z is a very small number. So I guess I might need to do a math f dot EBS of this, because I don't know, it might be a small negative number, it might be a slightly small positive number. So is less than 0.1f. Right. Then we don't want to do this calculation necessarily, right? Okay, so let's just keep that as a potential. Okay, now down here, let's do the calculation. So this is going to be our x over our z, right? Yeah, because if the z is very small, it tends to infinity. So yeah, so our x over our z. So we need to figure out how to get our x and our z. So let's just do something like that for now, so I can clearly distinguish. Okay. So our x, wait. Yeah, our x would just be our velocity. So the character velocity in the x direction. Okay, cool. So we could just do character move direction dot x multiplied by. Okay, so this gives me a. Yeah. This is not. This should just be the actual input, actually. Wait a minute. How exactly does this work? I'm just needing to check here. Character move direction might be too raw of a number. Yeah, this is just our input vector, so it's going to be 1. Its value is between 0 and 1. What I really want is a more calculated number. Yeah, something like this, where run speed do we just need velocity? I'm actually not too sure. What do we do with the move direction? Okay, maybe I need the velocity, not the move direction. Yeah, that might be what I need. Because the velocity... How the hell... Did I ever normalize these numbers? Or, I mean, what the hell am I doing here? I don't know if I do. It's interesting that I'm not then moving. So my biggest thing here is I'm thinking that maybe the character is not going to be running at the same speed in all directions. Unless the input vector kind of is already... Oh, okay, never mind, I'm a dumbass. Get movement vector normalized. I see. It starts normalized. That makes more sense. Okay, but I don't think we didn't need to really do this calculation. What am I doing? Yeah, because we could just get the velocity instead. We could just change this one to character velocity. Right, and then instead of the move direction, we could just do get velocity. Right, then we don't even need the character speed. Yeah, then we can do character velocity.x. Okay, what's wrong here? Yeah, okay, so we got the velocity in the x direction, so that's how far the character would be moving left to right, okay? And the z is the up and down. Yes. Okay, I think that's essentially all we really need. Okay, then the z direction, so this is the gap we're trying to close in this case. It's going to be very interesting to see if this actually works. But anyway, so the z direction. This would need to be the actual distance that can be covered by our little lizard. So this needs to be the speed of the lizard in some way. I don't know if I have that stored anywhere. Enemy movement basic, let's just see. Okay, manager enemy data dot movement speed. Okay, so we got a speed there, so we could just do the agent speed. Do I have the manager anymore? Yeah, so I could do manager dot okay, I think we need to decide whether we want to move up or down. Right, so that whether or not we're drawing this triangle up or down? Left and right. So for up and down, this already incorporates left and right, so it will be positive and negative depending on the player movement direction. This one, however, we need to figure out what our actual character position is relative to the... Yeah, okay, so we need to do float relative Z, and that is actually equal to this thing here. Whether or not it's positive or negative is going to make a difference here. Would it make a difference? It's gonna flip the triangle, but I don't think it actually makes a difference. Yeah, we just need the angle for now. We can figure this out later. We can use that later. We can calculate the angle. So the only thing it's gonna do is it's gonna take this triangle and well, it's going to flip it upside down like this. But that's still the X, and your Z would be upside down, but this angle size doesn't change. So we could just get that angle first. Yeah, let's just get the angle, that'd be fine. It's the same with if the X flips, then it's just this way, but the angle is still the same. Yeah, so we don't really care about that. Yeah. Okay, so we could just use the manager dot enemy data dot movement speed. Okay, so that's the first part, and then we need to add to this wait a minute. We might need the direction now that I think about it. Because if the character is actually moving down relative to this, and I'm using a positive number, I might be trying to do this and then subtracting, but I should be adding, making the side longer. Okay, so I need to know this needs to be multiplied by plus or minus depending on the movement speed, the relative Z. Okay, but regardless, we're going to have to add the character velocity dot Z. Right, those should be our two, so we just need to figure out how we can get this thing to be... We need a multiple here. There's going to just be a float relative Z multiple, and we'll just do something dumb like this. If relative Z greater than 0, just make this equal to 1, I think. So if it's, we make it greater than 0, and then if for some reason it's, just do this. Okay, so we make relative Z multiple equal to 1, and if relative Z is less than 0, we make the multiple equal to -1. So here we do relative. Okay, the movement speed multiplied by our relative Z multiple. Okay, there we go. Okay, that's a bit weird, I think, but this should give us an angle. That's a big should. Let's do a debug. Log, and let's print out this angle. That's gonna be interesting. This is also gonna be, this should be a, this is gonna be in radians. Which is not necessarily a bad thing. I just can't read radians quickly and understand what they are saying. Math. I need math f dot radians to degree. Do I give it the angle like this? Not quite. Oh, that's just a constant? Oh, that's insane. Okay. So we just multiply this by the angle. My genade. Okay, multiply by the angle. That should give us our angle. Okay, we'll test this now. I might have to do some manipulation of that angle, but... Okay, so we have calculate destination. I kind of want this guy to not use basic movement at the moment. Okay, so what I'm gonna do here is on our movement basic dot do basic movement equals false. Just for now. And that should mean that he doesn't move for now. Okay, do we just need to calculate this at some point? So let's do a public, well, I enumerable is it? No, it's an I enumerator. Right. Movement update. Okay. Yield return wait for seconds. New wait for seconds 0.1, and then every time we did that, we want to do calculate destination. Okay, and you know what? We can do start coroutine movement update. Okay. We'll see what this does. We'll see what this does. It's gonna be interesting. Okay, but I'm ready for it. So I just want to see what the angles does. Now I'm anticipating some problems. Also, debug.log z relative z too small. So in this case, we want to do angle. Well, debug.log 0 for the angle. And what we need to do here, okay, map. Okay, this is just our relative z. Now some of these might be backwards, so we'll see. Yeah, since we calculate the relative z, might as well do this. Oh, and return. Right, so if that ever happens, we don't actually go and try to do the arctan calculation. Okay. Let's have a go. Let's see how successful we were at coding stuff. Okay, it's not happy about something. I don't think I have compile errors. Why does it think I have compile errors? Don't be like that. It's just a million warnings. Runtime initialization on load method attribute object cool. It's like, I don't know why is that a thing now? It never was, but now it is. Okay, let's go test and see what we get from our printout or the console. Ooh-wee. Ah, damn, why is it so cold today, man? Okay. We want to spawn one small melee enemy. Want to clear this. Where is he? Okay. I assume my coroutine never started. Oh man, I'm just a dumbass. Wait a minute. I didn't loop this. While true, do that, right? This should be like a pseudo update loop. So we need to loop it to calculate this. So I guess it got here. So the relative z was less than 0.1. Interesting. Tired today. I knew it. Okay, let's clear. Okay, 0, 0. I will grab the wizard and grab 1. Spawn. Play. Interesting. Don't want to collapse this, I don't think so. Okay, so he thinks we are... The Z is too small? Oh, it's because I'm not moving. Oh, that's interesting. Oh no! Oh no! He's awakened! Okay, so somehow the way I I made this work. Comes out to 0 quite often. And what does that actually mean? That means the angle. Ah, you know what I actually forgot about? Okay, so this gives us that angle, but we also need... I completely forgot about this pod. So here's the issue. I've made a blunder. So, okay, so I've been doing something wrong. So, but essentially, if the character is over here, I've been making the enemy straight up on the Z-axis, but what if the enemy's over here? Right now, and so let's say, and the character's moving this way. Obviously now what I'd like the enemy to do is something like this to intercept. Right, but what I haven't been doing is when I draw the triangle, to get the angle over here to do some of these calculations, I need to do either two things. I either need to complete this triangle, so take the positional offset into account to calculate the direction that we want to go into, or I need to draw a different type of triangle. Now, I can work with this type of triangle, just don't like to. I like working with right-angled triangles. Right, if I can avoid doing one of these where I use this angle here to calculate the trajectory, I will. I'm just gonna do this big fat angle there. So essentially what I need is I need to add the positional differences as well. Well, okay, wait a minute. Yes, I do need to do that going into it. But this would need to update yeah, so essentially if I'm not moving, then he's going to plot a course like this. If I am moving, he'll plot the red course. Theoretically, anyway, we'll see. This is probably not going to work exactly the way I want it to for a while. But, okay, I can at least recognize that I need to do this at the minimum. Now, there's some other funniness that could happen. So what could happen in this kind of case? What I want him to do is plot that course. Right. But now, I need to subtract this difference in position. Yeah. Okay, but essentially, it's the same. So we need to get our positions and do that first. Okay, so this would be an X problem. Okay, so currently we just use the character velocity.x, but we need the character position. Yeah, we need the relative Z and the relative X, essentially. No, transform.position.z. What are you thinking here? Right, something like that. And I want to do just something basic here, like just adding relative x, right? Not sure that this is the correct way. And I think I want to add the relative z as well. Now this would mean that it's very difficult for this all of this stuff to actually be negative. Well, it might be. That's a positional thing. But if we have velocity in the z direction, we need to do character velocity z here as well. I think. Okay, let's go try this out and see if... Okay, so I do think this is going to be better. I'm also not 100% sure where exactly these angles are reference, or you know what these angles even mean. That's yeah, that's kind of funny, but yeah. So we're going to see positive and negative numbers and all things like of that sort, but what do they actually mean? I don't know. I'll have to figure that out. Okay, so now we got a lot of numbers updating. So let's see what happens. Okay, so we need to check. So if I just come and stand below him, right? The angle is about 0, which is what we'd expect. Right, we'd expect him to wanna go straight down at a 0 angle. Okay? So let's go above him. And we stand still. It's also very close to 0. Okay. So the angle itself, as I suspected, is not sufficient in determining what the direction is I should run towards. Well, apparently, well, it might be a different thing. Okay, so if I'm in this quadrant, it's a positive 30 degrees. Oh, very interesting. This would be 45, 50 degrees. Relative z is too small. Okay, so that now we're on that. Now we're at negative 50, so it's about 52. Which is strange. That wouldn't make much sense to me. Okay, so some of this kind of makes sense. But some of this is definitely not correct. Okay, so let's see. What do we expect? Oopsie. So what we are expecting is something like this, right? So if this is the enemy and I'm standing over here, I'm expecting it to be 90 degrees. Right, because arctan of 90 degrees... well, no, arctan of infinity is 90 degrees, right? Yes. So this should be 90 degrees, but then... And this should be 0. So we should be getting angles from 0 to... So it's from 0 degrees to 90 degrees. And from the top... Now, it depends on the rotation as well. I can't remember exactly how all this works. I haven't done this in a while. But this should be 90, and then we should expect it to go either to 90 or to negative 90. Right, depending on the quadrant we are in. But they are 0 at the top and the bottom. And the same thing happens on this side where they are positive, negative. Now, if I remember this correctly, back in high school, for arctan, or for tan, this is plus, minus, plus, minus. I don't know how that works into this at all, but anyway. Okay, so this is what I'm expecting, but I'm seeing something like a 52. Doesn't make a lot of sense, so that would be... That would be something like, you know, if the character's over here, and I draw this triangle, this angle over here. Right, and if I get to here, and I draw this triangle, this angle over here should be much smaller, but it's not, so I'm doing something incorrect here with my positions or something, or maybe it's this enemy movement and the relative Z. It might be that. It might actually be this. It's offsetting my Z by some amount. Yeah, it's offsetting my Z. It's pushing it down, for instance. And then it wants to calculate this trajectory here. Wants to run over here. And not just towards the character. Okay. I see. So he still wants to kind of do an intercepting run. He doesn't just want to do a straight run towards the character because of the way I calculate these. Yeah. So this should then somehow this should all just be, there should be two angles if the character is moving and when the character is stationary, I would say. Because if he's moving, I do want to do the intercepting run thing. So I do want a bit of an offset for that angle. Well, what happens if I move in a straight? Well, then it's just 0. So then Yeah. This is a little complicated. Let's see something. So while I'm running, right? Okay, he knows not to. I think I need to give him. I need to make a target so I can see where he's trying to go. Oh wait, I could do that by just, yeah. Okay, so let's finish this math. But I think we're getting closer. We're definitely not there yet. But let's finish this math and see what exactly this is going to end up being. Right, okay, so we got the angle theoretically. Now what we need to do, since we have the angle, well, let's just clear up some board space over here. So we got the angle. That's fantastic. That gets us like 20% of the way there. Okay, so theoretically, again, let's just give this to ourselves. So we want to give him this position. We want to tell him to run there. We got the angle now to run at. So, okay, so this is where it gets interesting. So we got the angle. We now need to get a side length here. Right. Sort of. Okay. Alright, but let's say we know how fast the character is moving. Theoretically. Now I can't remember why I wanted to do this in the first place. I lost the thought. Okay, so we got the angle. That's nice for us, theoretically, if it's even correct. Now we just need to calculate the position that we want to go to. And that position would be based on the time it would take we essentially want to find the intercept between these two lines, right? Fantastic. I was not anticipating that. So you have two straight lines, and theoretically, we should be able to come up with formulas describing these two straight lines and find their intercepts. That sounds amazing. So we could make, okay, we could make the character's current position the origin. Right, then we have 1 point, let's say, which is the enemy's current position. And the character's current position is 0, 0 relative. So we can find a relative xy, which we already have. Okay, then the enemy would have an angle that he wants to travel along. So we have a point and we have a... well, we essentially have a slope, right? And we have y equals mx plus c. So let's see, we have 1 point, so we can plug in an x and y, we can calculate c, right? Then we have our formula. Okay, so we have that for the enemy, y equals mx plus c. Now for the character, okay, our point is the origin, and what we have is a slope, and c is 0. Right, so we have a line starting at the origin with a slope, and so it's just going to be y equals mx. Right, so the first thing we'd have to do is we have to set the two y's equal, let's say. Okay, to find the x-intercept. Yo, Brody! Good afternoon. I'm doing some interesting math today, it seems. Okay, we essentially want the point where x and y are the same. So we can do mx. Wait. No. So we can do m. What? Mx equals mx plus c. Two m's are obviously not the same. So what we expect is something like x would be equal to, let's see, so we take this over, we take out the x, it's m minus m, divide, so it's going to be c over m minus m. I've done it. I'm trying to do a interception calculation. So I want the characters or enemies to try and intercept your character based on the trajectory and the current position and all that stuff. So it's a bunch of vector maths. But I think I got it. I just got it right there. Look at that. Well, I got some of it. This is definitely not it, but it's some of it. Okay, so that's the x, and then the y is simply just equal to, well, mx, right? So we could just calculate that point. So then we'll have that point, and then we can say that is our destination. Okay, let's hope I don't forget why the hell I did any of this while I'm writing the function. Okay. So, okay, we need to set up some of these, sort of. Well, I guess. So this would be the x-intercept, so that would be whatever this constant is, but I don't know what that is. It's gonna be... Yeah, we need to figure it out. Okay, this is our angle. Somewhat. It's essentially this thing that I calculate here. That is our slope. Okay, so let's do this float slope. This is the enemy. Well, yeah, enemy slope, whatever. Equals all of this nonsense. Now, it might not be exactly that. I might be wrong, but bear with me. Okay, so we got the enemy slope. So then we just need to figure out a point on this line. Okay, so float enemy constant, or let's just do C equals. Okay, here we go. So we want to find C first before we can do this. So it's just going to be y minus mx, right? So the y, that is our relative z. Relative z minus our relative x multiplied by our slope. I can already feel this not working. But it's okay. It's okay. So we got the constant. Right, now, float our X. This is our X. Well, okay, so it's our... you know what? I'm gonna do a vector 2. Let's do a vector 3. Intercept equals just new. Okay, intercept dot x. I think that's the one I can calculate first, right? Yeah. Intercept.x equals c over m minus m. Okay. Oh, look at this thing. I think it knows something. It knows something. Maybe. Okay, so c divided by... Okay, so we need to do the slope of our character, which is just our velocity, minus the slope that we calculated for the enemy. Again, this is probably not entirely right. We'll see what it does. It's going to be very interesting. It's going to be very interesting. But... Wait, where am I? Okay, this should be the character velocity minus essentially... Oh, wait a minute. I mean, technically it's the character velocity in a way. But that doesn't give us a slope exactly. So it needs to be the x over character velocity dot z. No. Not exactly. Oh, this is not actually the slope. Because it's an x over y. Slope would be y over z. Aha. So 1 over is what I'm feeling here. Yeah, so the slope is 1 over this. Yeah, I'm just being dumb now. Okay, something like this, and now we can just use the enemy slope straight. Okay, and this is now the slope minus enemy slope. This is gonna be very interesting. Okay, so we got our x-intercept. Now, our intercept... Mousepad's being weird. Okay, our intercept dot z is equal to our slope, essentially. Wait. Yeah. It's just our slope multiplied by our intercept dot x. This is going to be fun. Oh, I can't wait to run this. Okay. Now, before I actually do anything with this, let's just do a debug.log and ask for our intercept before I give it to anything to do anything with it. Okay, now I don't know if this is going to be entirely... So I'm expecting... Yeah, this is going to be a difficult one. To verify, to validate. I guess the best way to validate if this is ever going to be anything like an accurate thing would be to do it with an actual moving enemy. So we can see that they are trying to intercept us. Let's see this. Quite a lot of code that I just wrote here for this little thing I'm trying to do. But I think it's gonna be worth it. I hope so. I hope it's gonna be worth it, and that I'm not just gonna end up giving it a random number instead. Like, go to the character, plus minus a random number. And then I already have the effect I wanted. I should probably have tried that first before I went down this rabbit hole. Because if I did that and the effect is good and satisfying, there's no reason to not just use that effect. Okay, so we'll grab the owl, we'll play, and we'll spawn an enemy. Okay, I see a lot of nans here, which is unfortunate. Okay, so let's see. So if I'm over here and I go up, oh, you know what? I need to add the player current position to the intercept. Okay, I'm getting a lot of nans for the Zs. Why would that be? What? Oh, I think I'm dividing by 0. Okay. Yeah, my Z velocity is 0. Okay. If character velocity dot Z equals 0, so we're not moving up and down. That essentially means our intercept dot Z equals 0. Yeah, don't calculate it. Else we can calculate it, right? Okay, and what we want to do here is we want to take our intercept and we want to add our character position. Well, maybe not right now. Yo, this guy. Yeah, it's getting somewhere. It's a little bit strange, not gonna lie. I won't tell no lie. It's weird. A little bit weird. Okay, so let's see if this is better. Yeah, because of the Z... Wait. Yeah, okay, it's already becoming a problem over here. The x-intercept would also be 0. Which is not true if... Okay, so let's think about this. So, okay, we can calculate these just normally when everything is fine. If my Z becomes 0, and our intercept on the Z 0, and our intercept dot x, so it's just a straight line. So it's 0 slope, so then it's just a intercept with the x-axis in that regard. So that the position that it will intercept with the x-axis. Right? So that would just be dependent on this one. So where x is equal to 0. No, y is equal to 0. Then x becomes equal to... Right? Y is equal to 0. Yeah, negative c over m. I'm still doing calculations here. Okay, so this would just be equal to negative c over enemy slope in this case. That is my x-intercept. Otherwise, it can be all of this nonsense. I think. I hope so. Yeah, I think I kind of made it... I don't know if I'm doing this math incorrectly, or maybe there's some vector calculus that I've forgotten. Some linear algebra that would have made this simpler, but I'm doing it from like... I feel like first principles, which means I'm doing a lot more math that I maybe need to. Okay, but let's see if this makes more sense. So now at least when our velocity is 0, it doesn't try to divide anything by 0, I hope. Yeah, I don't think it does. So let's see if our intercept calculations are now a little bit more reasonable. Yeah, because it got all the nans going. Yeah. I think this should be better. Let's give it a try. Spawn one enemy. Spawn. Oh, I paused the game. Okay. Okay, there's some problems here. So he doesn't try to intercept my character. Okay, so when I go at a diagonal, he tries, but not necessarily when I'm not at a diagonal. Yeah, he should always have... Some things are at least making sense. So you can see the position. So if I'm to the right of the character, the X value is always a positive number. If I'm to the left, it's always a negative number. But the up and the down doesn't seem to get calculated. Yeah, so he'll run to the right, but he's not going to run up and to the right. So my Z value is a problem still. Righto. So what is it doing with my Z? Okay, yeah, and the Z velocity is only becomes a thing when I use both my inputs. So, oh, that's interesting. Okay, because I don't calculate an intercept Z. If my character doesn't have a velocity in the Z direction. This is probably why you need quaternions. I don't know how they work. I've never used them, really, I don't think. Maybe I did, but I forgot. Okay, so let's... need a bigger canvas. Honestly, this guy, I'm not even sure that is what I'm doing anymore. I'm doing something, but it doesn't feel like I'm doing that. I think that was the intention, and then, you know, somewhere along the line, the math got a bit interesting, and now I am down some kind of a rabbit hole. Okay. So, we have 2 points. So, this works. So, if we have an enemy there, right, and we have a character there, or there, he can clearly identify that he needs to run to the right, at least, right? So that part works. The enemy knows, oh, he's to my right. That works somehow. And he also knows he's to my left. What he doesn't know is that I should also run up. So somehow I'm not giving him that information, which is weird to me. Now, if I look at this, okay, what I can see, okay, so I calculate an intercept. I got all my slopes and stuff. So let's see if there's anything funny going on here. We got the enemy slope. The enemy slope we get by... That works, right? The enemy slope works always because we always get an angle. Is it the correct angle? Maybe not, but it's an angle. So he knows he needs to run in a direction. Right. Now what I want is for the character then. Yeah, so the enemy knows and he can project a line, I guess, at that angle. Maybe I should do a gizmo. Just to see a few things, right? Because if I can visualize like a ray cast or something like that, just a line or something, that could help me a little bit. Can't remember how gizmos work. Is it on draw gizmo? I think so. public void on draw gizmos. Gizmo dot color green gizmos dot draw ray. Okay, what do we need for ray? Ray R. That doesn't help me at all. Okay, we'll play your game. We'll play your game. Okay. Ray. Okay, this is my. My character rotates by mouse or keyboard input, depending on whether they are trying to aim or not. Okay, so this ray should be my enemy aim ray. Right. Do I want to create a new ray or do I just want to update the ray? I don't know. Let's just create the ray, and then over here we can update the ray. Okay, let's set the origin equals transform dot position. That might not work exactly how I want, but yeah, because it's going to be in the ground probably, hey? Okay, then we can do enemy aim ray dot direction. Okay, so this is going to be transform dot position minus intercept. Okay, now the intercept should be offset by my character position. I think. Yes. Okay, this is going to be interesting. Character position here, because it's getting a. It should be doing that. Okay. Draw ray, enemy, aim ray. I have no idea how this is going to work, because the origin of the enemy A ray is too low, I think. Yeah, if I do it from the position, no, it's not exactly gonna work. I think this is gonna help me visualize things a little bit better, though. Transform dot position. Could I just do, you know what, vector 3 ray position equals new vector 3, and it's going to be transform position dot x z, and then I feel like the y should be 0.5. Something like that. I don't know. And then I just do ray position. Okay. And I haven't drawn a ray in a while, so this might not work. Let me just see if that works. And then we should have a better idea of what he's trying to aim at with that. And then we can also see what he's trying to aim at with the angle calculation that I do. Because maybe I've already solved the problem and then I made it overcomplicated somehow. I might have. I might have overcomplicated this. The more I think about it, yeah. Okay, spawn. Okay, the ray is nowhere to be seen. Oh, I should switch on gizmo, shouldn't I? Is the ray very small? Is that the ray? How the hell am I supposed to see that thing? Is it because it's hitting something that it's so small? Okay, that's not very useful. I literally can't see the damn thing. Okay, let's draw it higher, maybe? Like 3 units high? Right, then it's at least high enough so I don't have to... Yeah, so it doesn't hit anything. I don't know if it hits something. I don't know. I don't know how rays work. I don't know if it hits something. Does it just disappear after that? Or can it go through? Don't know why it's so small. I'm just giving it a direction, right? It should go forever. Or maybe there's another thing called ray length. Yeah. Let's see, ray cost unity. Okay, let's just try it. Here I come. Okay. I mean, that thing is tracking me somehow. Oh, it's because I gave it the character position plus an offset, that's right. And it seems like it's the exact opposite. Yeah, okay. I give it the character position as a minimum, so... It would seem like it's working, right? Why is it so short? Max distance. Why can't I set the max distance? Well, I could do debug.drawArray. I didn't know that. Let's see, what do you need for a line? A start, an end, a color, and a duration. That is exactly what I need, so we can get rid of all this other nonsense. Okay. Yeah, we can get rid of that. And that. Okay, we can just draw a line. So we can do a start transform.position. Again, it's going to be in the ground. Okay, let's just do a... Could we do a vector 3 dot up times 2. Just so only the Y vector goes up by 2 units. I think that should be fine. Okay, start, end, intercept plus character position. Okay, color. I don't know, color dot green. Duration, I think that's the last one. Let's do 0.1f. Okay, what does this look like? So it should start where I am and it should go to where it thinks the intercept is. Hopefully. I really hope this works because this is annoying me. I just need a way to visualize what is happening when I'm tweaking, right? Because I just don't know if I'm close or if I'm very far or anything like that. Okay. Yeah, visualization is pretty useful. Okay, let's spawn him. Oh, okay, look at that. Ah, okay. So we got a couple of issues here. Okay, so he's sort of tracking me. He's doing some interesting predictions there. Yeah, okay. So the prediction is completely wrong. So it looks backwards in some cases. Yeah, I think it is backwards. Yeah. I think it is backwards in some cases. Very interesting. Okay, but that's at least... Yeah, that's a backwards... okay. Prediction over there. Yeah, but this is already quite useful, just to see that I got all the stuff backwards, right? Okay. Yeah, it seemed actually like the entire intercept should be negative. We still have the Z problem, but if at least this is going to work, it's going to be interesting. Ooh-wee. Okay, so that offset is a bit unfortunate. Okay, no, making it negative seemed to confuse it even more. In some cases, like that seems right. And then it kind of loses the plot there. Okay. Okay, we might have to rethink the way we do this calculation. Okay, let's test the angle. Maybe my angle is the more correct way to do this. Okay, so we just need to think about what the angle represents. So that's the direction in which the air you should be running. So maybe it's something to do with the slope. Yeah, okay, so the slope. Okay, so the slope that I have, or the angle that I have, right, if we just had our character, let's see. If we just had our character at a position, and I have an angle of 20 degrees. Okay, so first of all, that angle is measured with the Z axis. Right? So it's a 20-degree angle relative to the Z. So I can calculate a direction to run into. Because I essentially have... Well, I have an angle relative to the Z axis. Okay. And this could be my speed, right? This could be my magnitude, could be my speed. So my hypotenuse here is equal to speed, so the character speed. And then I could just do y is equal to r. No. That is not true. That is not true. Why? How embarrassing. Okay, but we got the angle, so we just need the speed multiplied by cosine of the angle to get the y, and the speed multiplied by the sine of the angle to get the x, or the z and the x, and etc. Okay, so let's try something else. So we'll do vector 3 something else in intercept, right? Okay, we'll just okay, so our x, which in this case would be sine, so this would just be my movement speed. Okay, no problem. Cheers. Have a good dinner. Okay, so it's going to be our movement speed multiplied by math f dot sine of angle. Yeah. Something else, intercept dot z is going to be equal to manager dot enemy data So this is not exactly right, because the speed has something to do with... So this would get the direction going, and it can draw a line with an X and Y, but it's not the actual correct way to do this. Because of the way time works, we still need time in a way to work it out. Yeah, our velocity is going to make a difference, right? So this could draw a line maybe to some point, but it's not going to draw the line all the way to the character. Or maybe it does, actually, because I use the slope. This could give us a good direction. And we can draw a line somewhat. Yeah, potentially. Okay, so let's see. Draw line. Let's do this. We're gonna go Victor to up. Okay, yeah. So what we're gonna do, something else intercept, right? So this is now where we want to go, and not our character position, but our transform. So what this is gonna do, since it gives us an angle, and we get our movement speed, we get an offset from our current position, essentially. So we want to go to, right? Now, if this thing is actually going to intercept with our character correctly, I don't know. It might be too short, to be honest, this line. It might not actually reach the character. But we'll see what it does. I think this might actually already be something that I can work with. Okay, let's try it. Because I think my original angle calculation wasn't necessarily bad. I think when I converted it to a, function, I did that incorrectly. I think. I mean, I could be wrong. I am probably wrong, let's be honest. Probably, I'm just incorrect right now. Okay, so as I thought, the line doesn't reach me. I kind of expected that, but let's see if I can see the line at least. Okay. Okay, so it seems like the line is a little bit weird with the angle. Okay, kind of makes sense. Yeah, so sometimes it's okay. And sometimes it kind of just flips out entirely. So if you think about this, right? So if we run up, you can see he's gonna run to that point, essentially. Because he always takes into consideration his own velocity for the X. And then as I move, he adds to that velocity my velocity. So it goes up the angle because he knows he needs to run further. Okay, now, and then there's something wrong when the angle goes negative. Right, so all of this seems good. Okay, yeah, so right there he adds his velocity again. So he's kind of run to my rear. Yeah, and look, even when, yeah, as soon as I go down. Yeah, so there's definitely something that works. So he's gonna, but he shouldn't try, yeah, he should be trying to intercept me a little bit more. Okay, so that's at least more promising, I think. So let's work with that. Let's build from there. So it seems like these intercepts are sort of correct. Okay. The only question is, how do I get these angles to make more sense? Or could I use the slope directly instead? Not use the angle in the first place? That would be first prize, I think. If I can just use the slope itself and not need to use the angle. That could give me a good direction to go into. Let's do something like this. Float Z dir equals, and that would be thus, essentially. I'm not entirely happy with, but let's look at that. And then float X dir. That would be this part over here. Right? If I had to separate them from one another. If you look at this, the Z direction, so I always tell him to run a little bit further than he could run. Okay, it's very important that that should only happen if the character velocity isn't 0. Because what I could do theoretically I could just so let's make this more straightforward, right? Let's think about it in the most straightforward way that we can. What if our the direction we have to run towards is our character velocity plus the relative Z position? That is where we run towards. So where is that point on the map, so to speak? Well, what we could do is we could just do on draw gizmos. Am I in a function? I am. What we could do is we could just do okay, let's do gizmos dot color green, whatever. Gizmos dot draw draw sphere. Yeah, we just need the center and the size. Okay, so what if we gave it these? This would give us the position that we think we need to aim towards. Right? Yeah, I think so. Okay, let's do a vector 3 aim point. Right. And then we can do aim point equals new X direction 0 Z direction. Yeah, we'll just do that, and then right here we'll give it the aim point, and okay. The aim point might not be correct here, but essentially that's what we want. So this is not going to be the aim point. This is just the direction that we need to go into. The aim point would be that direction multiplied by a movement speed, right? If I had to think about that, So we have a direction, and now this is where we're going to move towards. Yeah, so otherwise this point is just going to be like on top of me. So I need to multiply this by some distance, because this is a relative and this is a relative. Actually, it might not be normalized. Okay, let's try it just without multiplying and see what that does. Yeah, I multiplied it here, but this should... Okay, let's see, character velocity, relative Z. So it should at least put a point on top of my enemy, on my character. Right? Or unless the aim point... I believe this is relative as well, so it would draw it. The vector is... It's not going to draw it at the origin, right? It's going to draw it relative to my character, I believe. I hope so. It might draw it out on the origin, which is dumb, but I don't think it does. I've never had it do that before. Okay, let's give it a play and see. I think I also want to go grab me another cup of tea. So we'll check what this does. Go grab some tea. And we can come back. Okay, 0. I want at least one of those. Okay, so I think he's going to throw a gizmo somewhere. I don't see the gizmo. Of course, he drew it on the origin. Transform. Okay, maybe the aim point should be then plus transform dot position at least, right? Maybe I should do that at least. Oh, yeah. No, it makes sense now that I think about it. I've done this before. That should have happened. It is not a bug. It is a feature. I'm just dumb. Yeah, let's try again. Okay, let's spawn an enemy. Ah, there we go. Oh, look at this. Look at him aiming where I'm gonna be. Ah. Okay. That is pretty much what I wanted. Okay, so he knows how to aim. It's just... Okay, so the only thing this doesn't really account for is his own speed, right? And the distance between us. So maybe I can do that just in a dirty way. I'm gonna do it in a dirty way. But I'm gonna go grab myself a cup of tea. Maybe use the restroom. And I'll be back. We're getting there, guys. We're getting there. Don't worry. This is not... It's not gonna take much longer. I think. We'll see. Okay, give me 2 minutes. I'm back. Whoopsie. Did I just switch off the music? Oops. Okay. So we got this working sort of. Now, the only thing with this projection is, like, he should be aiming towards not where the character is going to be based on the character's velocity, but where the character is going to be based on the character's velocity and his current position. So, for instance, that target should be further away the more far I am away. Right, so that they want to run. Okay, so let's just do a stupid example. So he's over there, I'm running up. He's now going to run here, but he's quite far, and by the time he gets to me, I might be over there. Now, if I think about that, yeah, now I don't want them to run in an arc, because that's what they're going to do. I want them to run like this instead. Yeah. So if I leave it like this, what's going to happen is... Let me draw.
Let me draw.
Oh, what's going to happen? Oh, damn. What's going to happen is... I'm going to run to this point. They're going to come from here. And if I leave it like this, they're going to do what they do currently, which is annoying. Which is they run towards you, and then as you move, they do this. And if you have a lot of enemies, they keep doing this always. And they always they funnel themselves into the behind you. But if I already know that position based on my distance, if I give them, now it's not perfect, but if I give them this position instead, they'll run towards this position, it'll update, and then they'll do this and this and this instead. So this trajectory is going to become this instead of this thing where they follow you, which I think is way better. Okay. Let's go code that in a bad way without the complicated math, because I think the complicated math is just kind of doing nothing for me at the moment. In fact, I know it's not doing anything at the moment. I also don't need this line to be drawn. Okay. So, here's the thing. We want to calculate the distance, calculate how long it would take us to run there, and just add that. It's cold. Oh, this guy, are you back? Hello. Oh, it's exactly 20 minutes. Wow. You literally took 20 minutes. Precisely. You must be an old pro at this. Yeah. Well, according to the chat time, you said at 7:18 back in 20 minutes, and at 7:38 you said back lol. Okay. So let's update where this aim point is going to be. So as usual, I was overcomplicating things significantly, and I found a better way. Okay. We want to move this aim point by some amount. So I think it's going to be the velocity. So we need to calculate the distance, but I think we already have that. Actually, don't need the character speed. We have the relative position. We should be able to get the distance, no problem. But I think we already have the distance, so if we just do float distance equals movement basic dot distance to play. Yeah, we already got that. Okay. So let's do time. Travel time. Okay, let's do travel time. So we take the distance to player and we divide that by our movement speed. Right? That should give us our time. The time it would take us to get to the player. Okay. Then what we do is we take the velocity of the player and we multiply it by that amount of time. That should give us where the player is going to be in some amount of seconds. I think. I mean, that's how velocity normally works. But I'm not entirely sure what this velocity is, if I'm honest. Well, okay, this velocity actually has a magnitude. Yeah, that's why it was. Okay, yes. So we have a proper velocity, so it's not just a direction. Multiplied by time should give us a longer direction, longer distance. And the further away we are from the enemy, the further away this little ball should be from our character. Right. And that's the quick and dirty way that I should have used from the start, because it's already going to make it a couple of million times better. Let's give it a shot. Okay, play. We'll take the owl. Let's spawn in an enemy. Okay, so I'm standing still, so he's gonna come straight to me. Now, as soon as I move, I can't even see where that is. It's off screen. Now, that's not a bad thing. That just means that based on how fast the player is moving, just did this. Yeah. So he's going to try and get to that point over there, which is obviously a little bit further ahead, but he can tell based on the distance from the character that is how far he'd need to. That's how far I would travel. Now, it's not perfect because obviously, wait, I need to get the game in here. So it's not perfect in a couple of ways. So now you can see, since I'm closer, he's gonna go there. And now he's like, I'm gonna run around. Now he says, I'm just gonna wait here. And now he needs to actually run. But this is already a significant improvement, right? It's not perfect, but it's pretty good. So this is going to be our position that we're going to try and run towards. Now we need to be careful with this. I think if I just set the... You sat here in silence for 10 minutes. Good on you. So you came back, you're like, ah, shit, I'm too early. And you just sat there and said nothing. Oh no. Oh no, he knows. He knows I'm here. He's coming. Okay. Let's see what this does. Yeah, but effectively we got a good point now. So we don't need the angles or slopes or any of this other nonsense. We have an aim point. And apparently that's all we needed. Don't need any of that. I don't think we need any of this. Do we even need these relatives? Yeah. Okay, so I do use that at least. Okay, so now at least we got a good position. Do we need the relative really? No, I don't think we do. I think we could do this in a better way. Yeah. Yeah, we could just use the character position. We just do that. And then we don't need to calculate the relatives. Character position. So we travel to where the character's going to be, not where they are. Yeah. I might have been super overcomplicating this. Okay, and then we don't need to add our transformed opposition here. Because I'm not doing this relative thing anymore. 5 times. Wow, look at all that code just disappear. Also don't need this. Oh my word. And this might already be able to make, 80% of the difference I want. That last 20%, that fine tweaking, I think my problem was I was trying to get that last 20% of tweaking done before I even got the 80% to work. And I might not need to do the tweaking if the 80% is good enough, right? The good old 80-20 principle. Okay, so now we got an aim point, which I guess is something. So, let's see. We got an aim point and we calculate the destination couple of times. It gives us an aim point. Now what we should be doing from here is we should be running. Okay, let's see. Enemy movement basic. How does this one work? Okay, so it does basic movement, basic chase player. Okay, so we need something like this. We just have to move basic dot distance to player. Chase. Let's call this basic, or let's call this intercept layer. I like the sound of that. And what if we make this thing return a vector? So vector 3, right? And then we just return, well, kind of like having an aim point that I can look at. Return aim points. Yeah, I think that's better. Yeah, and we can do calculate destination right there, and we just need to run intercept player for the movement update. So check out distance, if stop, blah blah blah, agent.velocity equals true. Okay. That should work out. I believe. Okay, so we got the movement thingy updated. Movement update is working. Intercept player is working. We just need to be careful now whether or not we want them to update this necessarily. So let's see. So normally, movement do basic is false. I'm actually gonna leave that as false and never gonna. Okay, so what I might want to do here is private can move. This is a boolean. Now, yeah, this is kind of a dumb one. I think I can do this in a different way, but we can do basic movement. Just do can move equals true instead. On enable, we just make sure do basic movement is false, and we can do that every single time. We can start the coroutine and can move equal true. I'm not sure if there's anything else do basic movement does for us. Yeah, okay, no, there is a couple of things. Okay, so let's go see. So basic chase player can only happen if our state is running. Yeah, so I need a basic movement. Oh, geez, did I really do it this way? Like, did I write a whole movement script for every enemy? Essentially, that has something slightly different than just the basic stuff. I might have. let's go see what I did for like my ranged bomber enemy. Okay, so basic movement is false. I just set that to false. So here's all the movement stuff in update. Oh, okay, I see. So I went... Okay. I do run basic state. Okay, so I need to make this loop a little bit more complicated than I guess for this enemy. So we can start the movement update, that's okay, but then in this, the intercept player shouldn't happen just because, right? So we need to check a couple of things, right? For instance, if the state machine if we just want to look at the basic movement and copy that, or at least copy the idea. So basic movement, normally this would be called, because we said do basic movement can be done, but now I want that not to be the case, so it'll never do this. So essentially I need both of these functions to run. Or I just need all of this. Okay, so let's copy that. And let's go in here, right? So theoretically, this is everything that we need to do on each loop. Okay, so first of all, we need to do if can move. We can try all of this stuff, right? So if we can move, we can enable our agent. Then we can check if we are not currently running. If we are currently not running, then we stop the agent. We rotate to face player. That's fine. We could do that still, so that we can get from movement basic dot rotate to face player, right? Then if our distance to player is greater than our stop distance, and you can set our state to running. And then if our distance to player is less than our stop distance, and our state machine is not idle and not attacking, so we're not idling or attacking, then we can go into idle. Okay? And then right here, if we are running, we can do intercept player in this case. Ah, no, what am I doing? Okay, so we intercept player right there. Okay, so there's a little bit more to it, but at least we don't run this every frame, like with the frogs. Might have to go change that for them. Okay. Now we just need to do... Okay, let's see if I can find all the do basic movement. Okay, so it's false right at the beginning. Okay. Okay, so here I want can move to replace this. Okay, that should be fine. And so now we use can move and not do basic movement, and we do this every frame. And we intercept player, so we do a set destination, calculate a destination, calculate that based on the character position. Okay, this should work, and we are currently still throwing around a bunch of gizmos. We'll have to switch those off, but for now, let's go see a couple of, or one lizard to start with, and then maybe more. Let's see if they can chase us. What's wrong? There's no errors here. Do not perceive any errors. Rune item already defines. What the hell? What the hell happened here? I did not change anything here. What the hell? Did it? Why does it think I have multiple of these? I didn't understand what just happened. Did it duplicate them? It did? Enemy items coins. Oh, jeez. It created a new folder in enemies. All items. Get out! What the hell? How did that happen? Yeah, I was complaining it was duplicates, but that whole script got duplicated. Or the whole folder. And then obviously it detected some problems. Very strange. Very strange behavior. Okay. Only warnings. Only 71 warnings. That's probably not that bad, hey? Honestly, I've been looking at some of those warnings because they do annoy me, but I don't even know where to start fixing them. 72 would be impressive, huh? You reckon? A lot of them came when I updated my Unity version. A lot of them were created. Interestingly, he's not following me. Okay. Oh, look at that. Look at him intercepting me. Look at this clever guy. They know. Look at that. He changes direction. He follows the shortest path. He doesn't just run after me like a fool anymore. Oh, that's so much better. The only dumb thing is they still start not being able to move. I think I might have just... let's go here to movement. Oh, I need to make can move true, at least originally. And then whenever I disable it, I can make it true again. Yeah, or I could just do this in my enable function and not do it on this disable. Well, actually, you could do on disable false, like, I guess, if you really wanted, and just switch it on when you do on enable. I don't know which. Okay, there was a state change and it tried to do something. I don't need this rotate to face play anymore, actually. Okay, I need to be careful with this. I need to check if yeah, okay, my agents are still a bit broken sometimes. I'll figure that out now. Let's just see if this works. I'm gonna do a couple of enemies. So let's do like 20 enemies and see if they do the bunching, or how bad the bunching is now that they try and intercept you instead of just following you like a fool. I don't think it's going to make the biggest difference in the world, necessarily, but it could. Okay, let's switch off the gizmos. Let's spawn 20 and see what they are doing. That's kind of weird. Look at them. Okay, there's definitely some improvements that could be made. Look at them just. Synchronized running. Look at that. I don't think they understand exactly how this works. Yeah, it's a bit strange. I guess it's more noticeable with the fast characters as well. Yeah. If I do this now. Okay. What music is this? I don't know this music. Is this still my normal playlist? Ah. It is. Well, okay. Okay, that is interesting, yeah. Brody, we need a yeah, that's weird. This specifically when they're far away, they do it quite interestingly. Let's switch on the gizmos. Yeah, you can see that's now where they aim. This is the weird one, right? When I run through them, some of them like, whoa, yes, he's gonna come towards me. And look at that, he's now running away from me infinitely. Because he's trying to predict where I'm gonna go, but he doesn't realize that he could just turn around and hit me in the face. That's an interesting one, I must say. I hadn't thought this is gonna be the result. Yeah, I don't think it's the same with slower characters. I mean, it is sort of, but it's not as bad. Okay, whoopsie. So what would be a good way? We need to check. Oh, we need to figure out whether or not the character is coming towards you, right? If the character is coming towards you, even though they would be behind you eventually, you shouldn't run away from them. Yeah, because I think if you are the duck, for instance, let's see, where do they spawn? If you're fast enough, yeah, look at this, look at this. I could just make them run away from me. Yeah, that's definitely not the behavior I would expect. And you can get them to line up nicely now. Okay. It's a little weird, I'm not gonna lie. It's a little strange. Let's try that again so we can spawn them and just run towards them. Look at that. It's like, I know where you're gonna be, and they run away. Okay. So we should definitely... That is not exactly what I want them to do, right? If I run away from them, the behavior is better. But you can imagine, like, with the knight or something. Oh yeah, and look at that. They run towards... Oh, they're even more bunching now. Like, as soon as you turn around, they're like, oh wait, you're gonna be here. And they all stand in a line. Look at that. I can make them line up. Okay, so somehow I've made it worse. Interesting, interesting. Okay. So let's think about this. In our movement script, right? I think I can think about a few reasons this happens, right? So the first one, simple melee enemy movement, is right here. Movement distance to player greater than stop distance. That is a problem. So it shouldn't be distance to player. It should be distance to target or destination. Okay, so let's try and fix that part. Okay, so we have a private. Let's call this target. Right, that's where they're going to run towards. And then private float distance to target. Okay. Distance to target. So let's see. As we do this, so if we can move. Okay, we can get our target. So the target is reset. I guess we can make target just equals new, just in case so there's no null problems. Okay, so right here where we do distance to target greater than this thing, I think we can just calculate this once. So we can do distance to target equals, is it normally the target minus my current position? I think so. Yeah, okay, so distance to player is current, the target position minus my position dot magnitude. Okay. Oh, I'm still running the game. Alright, so it's going to be target minus my current position. Okay, wait, let's do this in brackets. So we're going to do target minus transform dot position dot magnitude. Right, something like this. And instead of checking if we are close to the player, we should check if we are close to our target. Okay, here we do distance to player. We don't have an initial target, so we need the player. Okay, we'll have to figure this out where sometimes the player becomes the target. Yeah, so if I had to think about this, it could be something like this, right? So here's the player, here's the enemy. If the player is moving and the enemy predicts, okay, he's going to move along this path to get to, you know, the point over there. What's currently happening is the enemy is saying like, oh, that's fantastic, I'll just go here. But then obviously this point gets updated and you get the enemy running away. So what I should do is I should have a way for the enemy to realize that they are going to cross paths with the character if they just stay put. Right, so what I could do... Need to be careful though. This happens in all axes. So what I could try is, let's say I do a line or something like this, and if there's a cross point, I tell him to rather just move towards the character. And not the predicted direction. So this is a little bit complicated. So what I could do is I could calculate a vector like this, and then I can do a, you know, perpendicular vector like that to calculate that position. It's a bit complicated. Oh, what we could do might be a case for a dot product. Hopefully not. So what we could do is maybe something like this, right? So we got a radius. Which is the distance the player is going to be moving, right? So let's not... I need to zoom out here if I want to get everything in this circle. Okay, let's just pretend that thing is correctly aligned. Okay, but anyway, we can have this radius, right? And we can say... No, this also doesn't really work. Oh. So what I'm thinking is we can say that if the enemy is within the radius, just go to the, you know, just instead of doing whatever you were gonna do, just run towards the character. But then I kind of this whole thing doesn't really work because the enemies will be inside of the radius a lot of the time. So is the intersection thing better? But the thing is, if the enemy is here, they'd be able to run towards this point instead of running towards that point to intercept the player. Now, if they are there, they try to run here. Oh, this is such a... They always try to run kind of like in a circle based on their distance. No, not exactly, but they should definitely not be running away. Unless I give them like a type of an aggro distance where if not the player gets within this range. This is a complicated problem. Pathfinding and doing all this stuff is weird. I kind of want to see what this distance to target does, if that's any better. I think it will be different, might not be better, but it's going to be different in some ways. So let's just see what that does. Let's just try that. See what we can see. Some of the behavior might be slightly different, but I don't think this is our final change. This won't fix the problem for us. Might have to go look up my linear algebra, vector calculus, all those good things, because I've forgotten most of it. Try and remember what. I think if I could just define the behavior well on paper, I should be able to come up with a algorithm that works, but I'm not even sure what I actually want on paper. So, or how to describe it, you know what I mean. Okay, so let's see. Now they're running away still, so I kind of expected that part. Okay. Yeah, we got this one who... Oh, that's interesting. So now they can actually get stuck. Oh, that's interesting. That's very strange. I'm just making up words. I might be making up words, you're right. Vector linear algebra. Yeah, that sounds about right. What was I saying? That's some other thing. I think I said vector calculus or... No, what did I say? I can't remember. Whatever. We all know what I'm talking about, right? Alright, so it seems like there's now a new thing that I introduced where the characters can't move anymore. You don't remember either. Okay, so somehow they now get stuck. That's actually interesting. I wonder why they got stuck now. With using distance to target instead. So obviously distance to target gets calculated. Agent not enabled is true. Then we calculate the distance to the target. That'll be our target. Ooh, okay, wait a minute. If we don't calculate the destination, we don't get the... we don't get the new target. So maybe we need to calculate the destination. That could be a thing. Yeah, maybe we need to calculate the destination there instead. And over here we can just do the target. I don't need to calculate it again. Yeah, this might be it. I didn't calculate it. So I calculated once, I get to the target, and then it never calculates again because it's like, but I'm at the target. And because I'm not running intercept player every time. Yeah, that's the problem. Okay, but I should be able to calculate it now, every time here. And just plug in the target there and we should be fine. We should be okay. So let's see if I at least got it. Okay, so this is obviously still not fixing the problem, but we'll see. I might have to go think about this long and hard. Okay, let's get out 20 enemies. Let's spawn and run towards them. Okay. Interestingly. I mean, yeah, it doesn't feel any different out at the moment. Ooh. As soon as I take a fast character, which is faster, the duck or the robin? Oh, wait a minute, I just want to see something. So if I run... I want to see if I can get them to stand in a straight line again. I did it with the chicken knight quite successfully. Oh, they just stop and wait for me, okay. Yeah, so they just stop and kind of wait. It's so fast, the behavior, it's difficult to exactly tell what's going through their minds. Yeah, okay, so they are trying to get ahead of me. Right, if I turn around, they obviously... For a split second, they try to go to that line, but then they see... This might be an update speed problem as well. So that, you know, when I turn around, they immediately want to stop first. And probably if my update cycles were a bit faster, it might not seem that jarring. So it seems like it's somewhat better. I guess what I could do, actually, is I could check. Maybe I should do a vector comparison instead. To see whether or not what the character is trying to do, or what the enemy is trying to do, is actually making him run away instead of towards the character. Okay, I think I'm gonna call it there. I'll go think about this some more, and I'll come up with a solution hopefully today, and then I'll implement it, and all of you can be super impressed tomorrow when I show you the solution. How's that for a plan? I think that's a perfect plan. It's pretty much flawless, right? Okay, let's see if there's anybody I can get raid. Okay, that's interesting. I don't see. Let's see, following. We can go say hi to Ice Bear again. He's a pretty chill dude. And what else do I need to press here? The buttons. Ending screen. Let's go. Okay, guys. Thanks for joining me today. It's a bit of a toughie, but I think this is going to be worth it. I think if we can get the enemy movement proper sorted out, we'll have a much better game in our hands. So anyway, cheers.